Welcome back. We're doing the sorry about that. Public. We're doing the casual game mechanics. This one we're doing a puzzle, so it's based on so many mobile games of the same type, where you just kind of need to fill the tiles, find the best way to get it with the least amount of moves, and then win. So we just show you the result of what we're doing. There we go. We're going around the scene, filling up the scene with color. And when we get to the end with one more tile, it says winner, winner, chicken dinner at the bottom left there, which means we have won. So we're going to be doing something along these lines. So I'm going to move this off to the side, go to the scene that has nothing in it. Okay, let's talk about prep. So all I did was, let me just change this over to my C# equivalent so I don't have the graph from Bolt. We select our character, and on the character I've added a sphere collider, which comes by default, and a rigid body. Just left it as continuous so I get a better collision detection, and that's all we have on that. As far as the levels, just used cubes from Unity's cubes, and just tagged these with a layer called blockers. So we're going to need this layer at a later stage, so make sure to tag any object that is going to stop the player from moving with a layer of blocker. Now the floor is another cube, it's just being reduced in size. It's got a mesh collider, because I'm lazy that way. It should have been a box collider, and it's also got a box collider, which is set to is trigger, and it's just a little bit smaller, so that if my ball goes past another box collider, it doesn't change all the neighboring cubes, floors, to change color with it. So I just made it smaller so that we can get a better. We can even make it a little bit smaller, 0.25 and 0.25. I don't care about the height, to be honest. The height can stay the player height. I'm going to apply that because it's a prefab, so it applies to all the others. Remember to set it to is trigger, so this works, and that's it. That's all I've got. Is just a small level design that I took directly from one of the games so that I could just get going. So I built this really quickly out of Unity cubes. Okay, so let's get going. This is all we have. That's the game view. I just changed the camera color to match the color of the blocks so that it kind of looks like it blends seamlessly on the sides. And then we can put UI elements on either side. Because we're not doing for a mobile device, we can actually just use all the space on the sides for tracking the amount of moves you've made and the amount of moves you need to get X amount of stars or whatever it is that you're doing. So I'm going to go into my scripts, and we're going to create a new script. Don't call it the script, it's just me calling it, so that's what I've done. Everything else I'm just calling it puzzle controller. There we go. Wait for it to recompile. If you got Bolt installed, you'll realize the Bolt window will pop up just to remind you that everything has been recompiled, and the window pops up just to annoy you. So that's what it does. So grab the puzzle controller, drag it onto my prefab ball, and I'm going to open up my script. I hate it when it opens up on the other window. There we go. So we got your standard Unity script with your start and update, and we're going to be using the rigid body to move this object. So we're going to do, but we're not doing velocity or force again. We're doing a move position. I found adding force or velocity, whenever the ball unintentionally hit the wall on the side, it would kind of veer off track. So I wanted to move in straight lines. So I'm using a move position. But I also wanted to kind of, when it hits the wall, it stops moving. If I used a transform.translate or transform.position, it would still collide with the wall, but it would keep trying to go through the wall. So I'm going to remove the start because we're going to use an awake function. So we don't need to actually just remove all of this code. Let's start from fresh. There we go. Okay, so what do we need? We need a ball speed. So we're going to create a serialized field so we can access that in the editor and not any of the other scripts. It's going to be a float, and we're going to call this ball speed. If you're wondering why I put an underscore in front of the names, it's just so that I can tell the difference between one of my variables or one of Unity variables or even another coder's variables. So I'm going to put this as a default value of 10. I'm now going to duplicate this, Control Shift D to duplicate that line, and I'm going to call this one the ray distance. We need a variable for the raycast distance, And this needs to be a little bit bigger than the Unity standard size ball, which is 0.5. So I'm going to make it like 0.6 just to make the raycast just outside of the borders of the player. You can tweak this to refine. The bigger the value, the quicker he'll change direction. And the smaller the value, he'll have to get really close to the wall before he can change his direction. So the way I played this game, and you can only move in a single direction, and the only time you can move again is when the ball stops or gets to a standstill. So that's what this ray distance is going to be there for. Next one's another serialized field. This one's going to be a layer mask, because whenever I work with ray casting, I like to work with layers. It gives me a reliable result. And then the last one is another serialized field, and this one's going to be what is the color that we're going to apply to the overlapping tiles. So I'm just going to call it overlapping color. What is the overlapping color that we're going to change the tiles that we moved over going to be? So those are all the exposed variables. I'm going to give 2 line spacing between, and like a 1 spacing between the variables, and these are going to be all the private variables. So private. This one's going to be the rigid body, because remember, we need access to the rigid body to be able to use it. The next one's going to be a private int. We're going to call this let's call it total tiles in scene. So the amount of tiles we have in the level. Because remember, we need to figure out when have we run out of tiles and what we can do. Originally, this was a layer mask, and it was a list, and I was just like, I feel that we should first find there are easier ways or quicker ways to do this. A list works really well, trust me, but let's just kind of start at the bottom and work our way up. So that is the amount of tiles we have in the scene. The next one I want to store, this is going to be a vector 2, my input. So let's call that input. I want to store my input whenever I press a button. And then the next one is going to be a private vector 3, and we're calling this direction. So this is going to be the direction that we use to move the character around and for our raycast. So it's going to be equal to, and this is going to be a new vector 3, and because of, I'll show you why I'm putting these values now. It's going to be -1, 0, and 0. This might change based on where your character starts in the level. So you might want to choose a better way to do this, but let's go back to Unity just to show you what's happening. Okay, so my character starts on the left here. So I want the raycast to come back as true in the beginning. So I'm going to raycast, give it a default starting raycast position towards this wall here. Because if it's touching a wall, that is when we could move. I could have also pushed it up towards this side, but I'm doing it towards the -1 value so that it hits this wall over here. That's all I'm doing. Okay, while we're here, let's change our layer to blockers, and let's just change this color to, I guess, similar color to the player. There we go. So even though the alpha makes no difference, I'm just going to make sure it's set up. And now we can go back to our codes. I just wanted you to know where I'm setting this value here. Okay, so the next one is going to be a private bool. And this one is can we move? Can move. So can we move the character, which means will input be considered when moving? And then the last one is just for fun. It's going to be an int, and this is going to count the amount of moves. So movement count. So how many times have we moved in the level, so we can see if we get 3 stars, 2 stars, whatever we want to do. So those are all the variables we need, divided into the visible variables and the private variables. So we need to start by when this game object is awake, we are going to get the rigid body. We're saying get component. Why is my get component not working? I'll tell you how to resolve that issue now. I'm just typing it out complete because it's not auto completing for me. Rigid body is spelled correctly. Let me just copy that one up there and paste it in here. There we go. was a lowercase b, not uppercase. So I'll go and show you how to resolve that issue. Let's try this whole get component again. No, now it works. That's weird. It's just there are a few bugs for using Unity with Visual Studio Code. In previous videos, I've kind of shown you how to go into your project, your preferences, and change your external, all that stuff. So just I'll go again when we go back to Unity. I'll show you. So now that we've got the rigid body, I'm going to go I tried to do this. I was lazy, so I went and said the total tiles in scene is equal to, and I try to do this. It doesn't work. It works really well in Bolt. So find object with tag, and the tag is platform. Let me just show you where I'm getting that name. So I tried that because in Bolt it works great. You can do that. You can just simply get dot count and get the count value of, why is dot count? I think it's dot count like that. So you can't do that here, so we're going to do it this the way it should be. So we're going to do a for each, and let's just call this tile, just so we know what we're looking at. And the collection is going to be game object dot find objects, game objects with tag. The tag is, this is where you set your own tag. So let me talk about where that tag is coming from. So if I go back to Unity, I did mention we created a layer for the walls, but we also created a tag for the floor called platform. So it's now going to find all the objects with this tag, and inside here all we're going to say is total tiles in scene plus means it adds 1 to your tile count. This is exactly the same as going total scenes is equal to total tiles in scene plus 1, or it's the same thing as saying total scenes plus equals 1. So these three lines of code do the exact same thing. This is a nice, quick, neat way of saying add 1. And so that's what we're doing. We're adding 1 there, and we're adding 1 there. So that's all plus does. So if you ever wonder, if you ever see other videos and you're just saying plus or minus, you're subtracting in a whole number, 1, a very specific. So if you don't use plus if you want to say add 10, for example, because that plus is not going to work. That's only doing 1 at a time, incrementally. So we're going to remove those. I just wanted to kind of show you. So all we're doing is adding to the total amount of tiles. So just to see that this is working, I'm going to change this variable to public for the time being. Just leave it public, and let's go back to Unity to see if when we start the game, do we get the correct amount of tiles, which I think is 49 in this scene. Let me go back to my player so we can see it. So we can see total tiles in the scene. I'm going to push play, and let's see what the result is. We just get out of full screen. There we go, 49 tiles. We have 49 tiles in the scene that we need to move over in order to win the game. So that's already working. And it's a good start. Okay, so now that we've done everything that needs to be in the awake, remember we're using rigid bodies. So I'm going to do all my input in the update, but I'm doing all my movement in a fixed update. So we're going to start with the easy part. We're going to do the actual movement. That code is going to be quick, and everything that goes in the update is going to, it's not a lot of work, but it's going to take a little more time. So let's go rb.movePosition. Now remember, move position is like doing a transformed opposition. So we need to get, in here we need to go rb.position. So get the current position of the object. Let's add, and what do we want to add? We want to add our direction, that variable we created. What did I call it? Yeah, there it is, direction. I don't know why it's not picking up. And we're multiplying that direction by two factors. The ball speed, which I'm quite sure we have up there. There it is. Sorry, my IntelliSense is being not so intelligent. And then it's going to be time.fixed delta time. So what exactly are we doing there? We're saying move the object from the current location, add the direction, which is either the direction is going to give you a value of 1, 0, or -1. So that in order for it to move faster, we have to take that -1, for example, multiply it by the ball speed, which is 10, so which gives us -10, then multiply that by the fixed delta time, which is going to drop it down to significantly. I think it's going to multiply that by 0.03 or something, which is, I think, Unity's default time step for a fixed delta time. And then that's how many units the object is going to move. So that's all we did in the update. That's how we move the object. Now we need to tell direction what that is, so that we can actually move the object in the correct direction based on our input. And that's where we go into our update. So in our update, I created an input variable. We say input.x. Let's consider x to be our side-to-side movement. It's going to be equal to input.get axis raw. Let's try that again. Get axis raw, 2 round brackets, quotation marks, and this is going to be for our horizontal movement. And we're going to do the same thing. I'm duplicating that line of code, changing this to be a Y instead, and change this to be the vertical. We'll talk about where I'm getting these horizontal and vertical quickly. I'm not just making these names up. They're part of the input manager in Unity's default settings. We're still using the old input system. We're not using the new input system, unfortunately. We can do it in code, but I wanted all my tutorials kind of need to be one-to-one between my Bolt and C#. So once the input system is properly integrated into Bolt, then I'll start moving over to the new input system. Okay, so we're going to go Edit, Project Settings, and we go to our Input Manager. Notice how there is a horizontal and a vertical. If I open these up, it says if I press the left arrow or the right arrow, or I press the A key or the D key, then I'm moving side to side, I'm moving horizontal. And then the vertical says if I'm pressing the up or down arrow keys, the S or the W, then I am moving vertical. Notice how we can have multiples. This one down here is saying if I move my left analog stick side to side, I'll be able to move horizontal. And in the vertical one, as you guessed, if I grab my left analog stick and move it up and down, then I'm going to be able to move up and down in the y-axis. So that's where I'm getting those values. I'm not just kind of thumb sucking those values from something. So now that we've got that, I just want to store these values to check to see if those values are being pressed or not. There are better ways to do this, but I just found this to be the nicest way, at least for me. So we're going to put a comment here. Actually, let's put a comment above this. Say get player input. That's what we're doing there. And down here, we're going to put another comment. We're going to call this if player input horizon, if I could spell, is true and vertical is false, and we can move. So what we're saying here is only move the character horizontally if horizontal is true. My keyboard is so crap. And vertical is false, and we can move. Remember, we have a can move variable. So how are we going to do the can move variable? We might as well go ahead and do that in the line above it. We're going to say can move is equal to, this is where we do the raycast. So we're going to go and say physics.raycast, and a raycast can take in several. You can see we have a lot of overloads here. We got a few different options of what a raycast needs. So in my case, I want to say start at the player position, then go into the direction. That variable that we created, not minus, direction, okay. And then after that, we are going to say how far into the distance. So that's where our ray distance comes into play. So how far into the world before the raycast dies. And then the last one is what layer are we looking for. So we're simply, when you do a I'm putting equal signs all over the place. My keyboard is freaking out. Okay, so all we're doing here, the raycasts can be handled in different ways. The only information I care about from this raycast is whether it's true or false. Did you hit something in this layer or not? So now that we have this, we can continue forward and use that raycast to do stuff. Okay. So the direction, remember at the start the direction is -1. So let's see that raycast come back as false. So I'm going to go and choose can move and make this public so I can show you how that's working. Because it's going to be raycasting in this direction. I'm going to split the screen so I can move it. Notice how the variable is false. When we start the game, it should hit this wall here and come back as true. But notice how when I move it away from the wall, it went false. There we go. So we know the raycast is working. Now in here we're going to do two if statements. So if, and we're going to copy this if statement. Don't worry, we're just going to duplicate it after we're done. So the first one is input.get button down. What button are we looking for? Horizontal. Am I pressing the horizontal button? The reason we're not using input.get x is greater or not equal to 0. I was getting some weird issues with my movement count. So we're just getting the button. If we're pressing the horizontal button and input.y is not equal to 0, or is equal to 0, so which means, am I pressing this button? I wonder if we could use input.get button up. We'll try that afterwards. So if we're pressing right, but up is not being pressed, and the last one is can we move based on the raycast. So we're checking to see if all of these are true. So am I pressing the button? Is this button not being pressed? And can move is true. If that's the case, we're going to do a few things. We're just going to say update the direction variable to be equal to the vector3 dot right, because we're moving right. We're going to multiply that by our input dot x. The reason I'm doing that, if you're wondering, is using again my keyboard is acting up, is this value can either be positive or negative, and then based on that we're going to change whether we're going left or right. Negative going left, positive going right. Okay, so let's try this out to see what happens. Then we can come in here and try something with this code here, see if it works. It's always nice to kind of learn, and I like doing a few things off the cuff in my videos just to kind of see what happens. So we should be able to spam the button as we go right, but we should only be able to go right once we hit the wall. So notice how when I go right, I'm hitting the button to go left. Only when I hit the wall there am I actually able to go left. Same thing goes right. So that raycast is gives me a certain amount of freedom. It's not completely it's not too close to the player, it's also not too long. Because just as I get to the wall, I'm able to change direction. Okay, so that's working quite nicely. Like I promised, let's try something. Don't do this on your end in case it doesn't work. We're just going to copy this section of code here. We're going to go input.get button, and this time we're getting up, and it's going to be vertical. So let's see. Will it acknowledge that? Because this only fires when you actually press the button. So I'm interested to see if I'm not actually pressing the button, will this work? If it doesn't move now, then we know that that code logic is flawed. It doesn't work. It's not recognizing that the button is up. Yeah, there we go. Okay, so we're going to move that back to the way it was, which is fine. And that's it. That's the movement. So now what we're going to do is just do the fancy stuff. We're going to do the movement count ++. So every time I hit the button, I'm going to update my movement count. The amount of times click is the amount of times I move. And then all we're going to do is just select all of this and go Control-Shift-D if you have Sublime, like the Sublime shortcut keys installed, which is this one here. Sublime text key map settings. I find that to be a really nice shortcut key extension added to Visual Studio Code. But if you don't have that, all you do is go Control-C, Control-V, and that'll be it. So I'm also going to copy this line here and change what it says. So if the input vertical this time is true and horizontal is false. There we go. So that means we have to go and switch wherever it says vertical or horizontal, we're switching it around. So I'm going to paste that into there, and wherever there's a Y, we're going to replace it with an X. So are we pressing up, and is side to side false? And in here we're just changing that to be Y because we want the Y input, and we're no longer moving right, we're moving forward. Now if you're wondering where this forward and right and all of that kind of jazz comes from, let's go back to Unity and talk about that. I think I've mentioned in previous videos, but I kind of like to reiterate. Okay, so I'm going to grab this random cube in the middle here. So whenever we refer to right, we're looking at the red axis, which is our X. Whenever we're talking about forward, we're talking about our blue. And whenever we're talking about up, we're referring to the Y axis. So I'm using a vector 3 dot whatever it is. That means I'm using world coordinates. So the world X, the world Y, and the world Z. If I wanted to get the object's local up, so this Y is no longer facing up, it's kind of facing at a 45-ish degree angle, I would use a transform dot up, a transform dot right, and a transform dot forward. So be aware of that. When you start doing character controllers and stuff, you can't just use a vector 3 dot forward. You want to use the objects forward, so you're going to use a transform dot forward. Okay, so now we can test this. Actually, why was I in Unity and not testing this? I do not know. Sorry guys, it's a rough day. So I'm going to go right, and then I'm going to keep pressing down to see if I can move down. Notice how it didn't go down till I hit the wall. So if I go and try to go down, if I go here, try to go left, if I go here up again and try to go right, I have to wait till my object or my raycast hits a wall. So there we go, our movement is working. Can only move in one direction, kind of like Pac-Man. It keeps moving in that direction till you change direction. The difference between this and Pac-Man is we can only move in that direction when we've actually collided with something. So that's pretty much the major difference. Okay, so there we go. That movement is working. So if you're wondering how the raycast knows in what direction to go, remember we're updating the directional value in our code to be facing our input. So when I press right, the raycast goes in this direction. When I press the S key, the raycast starts here and goes down because it's going into the negative Z position. If I press up, it's going in the positive Z. If I press the A key, it's going in the negative 1. So it knows based on my input what direction it needs to face the raycast. Okay, so now it's time to do all the fancy stuff. So now that we have basic movement, we are going to add a untrigger enter. Remember, I see this a lot happen. Please do not put your untriggers inside of other methods or functions. They are their own function that stands alone. So please do not put them inside of another one. It does not work that way. So I'm going to put a comment above this one and say player movement, because that's actually what does the movement. The on trigger enter, we're going to add a comment here saying subtract number of tiles whenever we collide with something, and might as well just put in this line here, disable trigger and change color. That's all we're going to do here. We're subtracting the number of tiles, we're disabling the trigger, and changing the color of the object. But first we need to check to see if it is the correct tile. So we're going to do other.compare tag, and it's called platform. We just used it at the top here. So if it is a platform that we are entering a trigger of, we're going to do a few things. We're going to say the total tiles in scene minus minus. Remember we did plus plus earlier on. So this one does the exact same thing in the opposite direction. It subtracts 1. So we're going to remove 1 from every tile. So the problem with this is if we leave it as it is, every time I go through the same tile, I can keep going through it and I will run out of tiles and I could win the game by just moving between 2 tiles. So we want to say, okay, now that we've done this, we're going to grab the object we just overlapped with. We're going to get its component. We're getting the box collider. and we're going to go dot, and we're going to disable it. So we're going enabled is false. So we're turning off the collider on this object. Let's see this in action. So whenever we go through a collider, we should be setting its box collider, which is the one that's the trigger, to disabled. Remember to change the code based on the collider you have. Okay, so let's grab this collider. Actually, grab one of the ones in the middle. Notice how the box collider is enabled. When I move the character through it, that box collider will get disabled. Or it won't. What just happened? Other.get component. Please tell me I spelled platform right. Platform. I'm just going to copy this platform up here. Just make sure that that's right. That's a little embarrassing. Let's try that again and see if it happens. Sorry, why are you not disabling that collider? Equal to false, that is correct. So I'm going to debug this to see. So it's good when things break, so we can log it and say disable me. Let's just see if disable me gets fired. If it does, then there's some flaw in my logic, unless I've used the wrong on trigger. On trigger enter. Nope, not the wrong one. Okay, so it definitely fires disable me. Yes, so which means all of these colliders here's box collider should. Oh, it is. Okay, that is either a bug or I didn't save my script. Chances are I didn't save my script. So just make it a habit to save your scripts. That's probably what happened. So we know it's disabling. Now what I want to do is now change the color. So I'm going to go other.get component. Now the material is on something we call a mesh renderer. And we're going to go dot material dot color. We're getting the color on that material is equal to, and we have the overlapping color, so we're going to go overlapping color. Let's see if this works. I've now saved it. Correct. I'll show you why I'm calling the mesh renderer now quickly. So if I grab the object, oh no, let's wait for it to recompile. You can see the material over here, but you can't really access it. It doesn't have its own component. It's just visible, so you can change textures and colors and that sort of jazz. But I want to be able to get the mesh renderer because that's what renders it. Notice how it goes on and off. This is what renders the model to the scene. And underneath that, you'll see that there is a materials drop down. And in there is my material. So I'm saying find the mesh renderer, find the material, and set the materials color, which is over here, albedo, to the color I want. So let's see if this works. The first cube should turn blue. As I move over them, they should change color. What's cool about this is if we look at our player while we're playing, we are currently at 28 blocks left over. And we can just keep going around to see what happens, to see if our calculations are right. So we should be down to 1 tile in the scene, and when we go over it, we're successful. So that's all we have left now to do is what happens when we've won. So as we go through this collider, we're going to do another if statement. We're going to get our total tiles in scene, and we're going to say if it is less than or equal to 0. I always do an equals and less than, because especially when you're working with floating points can give you weird values. Like if you say my player health, when my player health is equal to 0, but you're using floats, it might actually end up being like 0.001 or negative 0.001, and coding is very unforgiving. Programs say, okay, if it's meant to be 0, if it's not 0, even if it's so close to 0, we'll still say technically you still have all the health in the world and you will not die, even after you've gone past the 0 and you have negative. So always, just for safety's sake, with the health, just say if it's equal to or less than the like 0, and then you should be fine. So we're going to log something here. Before I log something here, I'm going to put a comment just above there, actually. Say what happens, actually, whoa. I'm going to say put what happens in here when you complete the level. That's what we're doing here. So whatever happens when you complete the level will go inside here. So whatever happens when you complete the level goes in here. I'm just going to put in here winner, chicken dinner. Let's test that out and see what happens. Let's see the magic of the console telling me that I am a winner. Okay, so we're just I'm gonna try go a different route. There we go. What's nice is you can see that we can count the amount of we didn't actually expose the moves. We should do that after this. Wow, I'm sucking at this game so badly. There we go. There we go. Winner, chicken dinner. So I want to go quickly to the code just to show you that we can actually track the amount of movements we've made. I'm going to make that public. Again, you can make this private after the fact. I'm just making these public so you can see them. Just waiting for it to compile. And now we can see our movement count. So every time I click on the keyboard and I move, it should be adding 1 to that. So that's 1 move, 2 moves, 3, 4. We can track the amount of movements and then like get a lot of people to play your game, kind of gauge what is 5 star, 3 stars versus 2 stars. I've done this in 22 moves. So if I found that this is the best amount of moves you can do it, I could give that. If the player gets over like less than 25 moves, he gets 3 stars. If he gets somewhere between 25 and 35, he gets 2 stars, and anything above that, he gets 1 star. So you could do something along those lines, where you can use inside here, inside your code, where you check to see when you're out of tiles. Just do another check and compare your movement count and see if it's equal to this, then you get 5 stars. If you get this, it's 3 stars, whatever, how many stars you want to do. And that's pretty much it. Let's try it again one more time. We have our character moving around only when we are able in one single direction till we make contact with one of the colliders. And when we're done, we are winning. And let's see how many moves I did in that time. 22 again. I seem to be doing the same pattern every time. I can try a different pattern, a different rhythm. So let's go here. Let's go down instead. Go there. Go up. Go down there. Go across here. Oh, I'm sucking. How am I going to do this? Oh, wait. No. There we go. How many moves was that? That was 35 moves. Wow, that was quite bad. So that would be like a 1-star situation, I think. So that's it. So I hope this has helped, and keep an eye out. The series was coming to an end, but we still have at least 4 more videos. Hopefully this has helped. It's very rudimentary. There's a lot of things you can do. You could lerp the color of the platform that you're moving over. You could add particles or do a little bit of particle trail to show the direction of movement. You could do a lot of cool things with such a simple idea. And then you can spend so much time once the mechanics are done working on level design for those of you who enjoy that. So till I see you again, be safe and good luck.